Hello student. So today we discuss the last topic of the calculus that was remaining. The topic name is envelopes. And there is a sub part of that is your evolutes. So what is envelopes? So I think all of you know what is envelope. Like whenever you trying to send some letter or your document, you buy a envelope, right? So basically inside the envelope your document is there, or whatever you have written, that is there, right? So in terms of curves point of view, that is also like that. Okay, so I just give an example. For example, if I consider x minus a square plus y square is equal to a square, so where a belongs to R, if I say, so how this type of curve looks like. So you see this is looks like if your a is 0, not or not a, I think maybe this is b if you consider. So how this will be looks like. So basically b belongs to also, suppose b is some fixed number and you are varying your a, or we can consider more specifically, suppose this is your 1. So this is looks like around if this is your 1, suppose this is your minus 1, suppose, so you have a circle. This is not okay, this type of thing. Okay, so if you vary your a point only, okay, you will get this type of circle, because if your a change, so correspondingly you see the center of the circle will be changed, right? So in this way you have this type of thing. Okay, now you will learn what is envelope. Basically whenever you have some family of curve, right? Because here a is some parameter. Okay, so this is a family of curve. Why? Because depending for different value of a, you are getting different curve, right? So you can write this is your like f x comma y comma alpha, this type of curve, right? That is your x minus a square plus y square minus 1 equal to 0, this type of thing you can say. Okay, now how to find the envelope? Basically this is very basic. You have to eliminate your alpha or this parameter a using your f is equal to 0 and del f del a equal to 0. Okay, so if you do del f del a, so basically this from these two things, what is your job is your eliminate a. Okay, I think this type of job already have done whenever you first time differential is introduced, right? In your class 12 level. So how to eliminate that? There is some curve equation, you have to get some differential equation, how you are doing, so that type of thing. Okay, so what is your dfda? So you can say this is your 2 into x minus a, this is 0, right? So if you have to eliminate your a, so you see if you just substitute, that means x minus a equal to 0, right? So x minus a, if you substitute, so you have y square minus 1 equal to 0. So from there you have y equal to plus minus 1. So envelope equation here is y is equal to plus 1 and minus 1. So you can see this is your y is equal to 1 line and this is your y is equal to minus 1 line. Okay, so inside these two line you see there are this type of family of curve, right? So you will see I will send a and that book the corresponding chapter. Okay, you will see the picture is very nice there. They have not explained nicely, but still this is the logic. Okay, so how to find the envelope, it is clear, right? So your target should be you have to eliminate your parameter from that equation given and the differential with respect to the parameter equal to 0. From there you have to eliminate. Okay, okay, now yeah, this is done. Okay, now next suppose we are into next problem. Okay, I am just taking a random example, but in the book there are no this type of problem. Okay, so suppose find the problem is find the envelope of this thing y is equal to mx plus 1 by m, where m greater than 0 it is given. Okay, so what is your f of x comma y comma m? You can say this equation is your y minus mx minus 1 by m, right? This is equal to 0. And what is your del f del m? So del f del m is your minus x minus 1 by m square equal to 0, right? So from there basically you are getting, sorry, this will be plus, I think. Yeah, m square will be your one by x, right? So m is your 1 by root x. You have to eliminate this thing. So basically what is your y then? X into 1 by root x plus 1 by root x. So root x plus 1 by root x. So this is basically root x into y is equal to x plus 1. If you do that just simple if you just simplify, or we can simplify anything, I think it is enough. Okay, so in this way you have to find the envelope, right? Envelope. Okay, next, now you will find that type of problem is coming in your exam. I think in last 2-3 years I have seen this type of problem. Basically they will keep two parameter equation. Two parameter equation means here you see there is one parameter, right? That means this is one parameter curve. If you have f x y alpha beta, this type of thing, or m comma n, okay, this type of thing. So how to tackle this type of problem? Okay, so in that type of problem basically they either they will give you some extra relation. Okay, yeah, so suppose they give this type of problem, if x comma okay, case of two parameter, so f of x comma y comma alpha comma beta, this is 0, and you have phi of alpha comma beta, this is 0. They will provide another relation. Okay, so what you have to do, suppose you are trying to find the envelope, so you can use either alpha derivative with respect to alpha or beta. This is your choice. Okay, suppose I am derivating with respect to alpha. Okay, so whenever you are doing with respect to alpha, okay, so the first one will be like del f del a plus del f del beta into d beta d alpha, because beta is also a relation of alpha, right? Because whenever phi of alpha beta equal to 0, that means you can say beta is a function of alpha, some function of g of alpha. So whenever you are doing partial derivative, you have to use the chain thing. Okay, so that's why you have this type of relation. And if you do the same thing for the second one, you have del phi del alpha plus del phi del beta into d beta d equal to 0. Now if you try to eliminate your this del beta del alpha, okay, you will get the relation this type, that del f del alpha divided by del phi del this alpha, right? Del f del beta by del phi del beta. This type of relation you are getting. Okay, so from there this is your new relation. Now you have to basically eliminate your alpha beta from your this 1 2 and this 3. Okay, so let's do on this type of one problem, and there will be one homework. Okay, find the envelopes of the family of coaxial says x square by a square y square by b square equal to 1, where parameters a b are connected by a to the power n plus b to the power n equal to c to the power n. So you can think this problem is, this is your f of x y a b, right? And this is your that thing. Here this c is another, c is some constant line thing. Okay, so basically what you have to do, you have to do the derivative with respect to either a or b. Okay, suppose we are doing with respect to a, right? Okay, so okay, so differentiating with respect to a, we have what you have, x square into minus 2 by a cube plus whenever you are doing this thing, so you see this is like del f del beta, right? So del f del b you have to use, then you have dvda. So minus with respect to b, this one will be what, minus 2 by b cube y square into dv dA equal to 0. And if you do the next one, you have n a to the power n minus 1 plus n b to the power n minus 1 into db dA equal to 0. Now if you eliminate your dvda, basically from here if you find your dvda and if you substitute this thing there, so what you will get, basically dv by dA I am getting minus n cancel, so minus a to the power n minus 1 by b to the power n minus 1. If you substitute there, this is your 1. Okay, so this is your 1, this is 2, this is 3, right? This is 4. substituting in 3. So what you have, minus minus you can cancel, so 2 also cancel, so x square by aq plus y square by bq into db dA value is your minus a to the power n minus 1 by b to the power n minus 1 equal to 0, right? So from there you have basically x square by a to the power n plus 2 equal to y square by b to the power n plus 2. All right, this is you have. So you can simplify this step like x square by a square. This is always, it is little bit tricky because you have to your main job is you have to eliminate your AB. Okay, so for this one you have to use some trick. So your final equation you expect that will be depending on x, y and c. That's it. AB will not be there. Okay, so y square by b square by b to the power n. So you practice all the example in that book PDF. Okay, I think that will be enough. And in this chapter, one question is for sure, maybe 3 or 6. Okay, so you have this thing. Now you know, if you add this in the above, so you have x square by a square plus y square by b square, and similarly a to the power n plus b to the power n. Okay, so from there you know the above one is your 1, right, and this lower one is your c to the power n. So from there you actually getting x square is your a to the power n plus 2 by c to the power n, and y square is also b to the power n plus 2 by c to the power n. Sorry, I find a to the power n and b to the power n. Basically you have to eliminate your a and b, so instead of that you write not this one, you just write a to the power n plus 2. This is your basically x square c to the power n, right, and b to the power n plus 2 equal to y square c to the power n. Just if you consider this and this, so from there you are getting this relation. And if you have this and this, so you have this relation. Okay, right? So in this way you have. Now what is your a basically? So a, you can say this is your x to the x square c to the power n whole to the power 1 by n minus 2. And what is your b? B is your y square c to the power n whole to the power 1 by n plus 2, right? So now you use the relation a to the power n plus b to the power n equal to c to the power n. If you substitute, so from there you will get x to the power 2n by n plus 2 plus y to the power 2n by n plus 2. And if you do the c type of thing, so you will get c to the power 2n by n plus 2. Okay, like that. So in this way you have to do. So main thing is this type of step is little bit tricky. You will see there are some problem like that, so you practice this type of problem. Okay. Okay, so this is your example. Now there are one more problem. This You practice, this is already given in your note, but you practice as like homework. Okay, so find the envelope of lines x by a plus y by b equal to 1, where meters are connected by a square plus b square is equal to c square. Okay, this type of problem. Next example. So that this is coming, I think, maybe if you see the last 10 years, so this question is coming 3 year. Okay, so that the envelopes is very easy, just you have two relation. Okay, f of x comma y comma a is 0 and del f del a, this two type of thing, and you have to eliminate the parameter, that's it. Okay, so that the problem is coming little bit tricky. So you have to understand what is your function with respect to which variable you have to do that variable. Okay, and how you eliminate, so that sometime become challenging. Okay, so that the envelope of circles so this is the problem. So basically what is given, you have a equation of circle. So you know what are the equation of the circle. Let x minus alpha square plus y minus beta square equal to a square. Let this is the general equation of circle, right? Equation of circle is this. Okay, now if it is, you know what are the center, alpha comma beta. Now this is saying the whose center, right? Whose center is satisfying this rectangular hyperbola. So center is your alpha beta. Now given alpha into beta is equal to c square, and it is also given that this is passing through 0 0, right? 1 is so alpha square plus beta square is equal to a square. These two things you have. Okay, now if you use alpha square plus beta square is equal to a square in your equation 1, so basically from there you will get using 2 in 1, what you have basically x square plus, if you just open the square bracket, okay, expand this type of formula, and if you use this thing you will get, right? And you have one more equation, alpha beta is equal to c square. Now this, you see, this is your previous problem. So you can think this is your f of x comma y comma alpha comma beta, and alpha beta is connected by this, right? Okay, now after onwards you can complete. Okay, basically if you do with respect to suppose beta, so try to find your del f del beta, and if you use this thing, so from this two thing you have to find. Okay, so remaining thing is your homework, and that is already given in that note. Okay, this is the thing. Okay, there are one more thing, that is your evolutes. Okay, so what is this envelope? Basically you see, whenever you are dealing with envelope, basically you see that envelope is like some tangent thing, right? You see, at this point you say this is your tangent, this is your tangent, right? So intersection of your tangent of all the curves, right? From there you are getting this type of thing. But whenever you will dealing with normal, that will be your envelopes. Okay, so what is the envelopes? First you have to find the what are the normal of the curve, and then you have to find the envelope of that. Okay, so envelope is your, you have given a family of curves, suppose given a family of curve, then you have to find the normal of curve. Okay, so whenever you are finding your normal of that curve, you will see that there will be some independent parameter. This thing already you have done in your application of calculus in your higher secondary level, right? Tangent and normal chapter. So you know how to find the normal. Now after that, find envelope of normal of that curve. Okay, so I just do one example, that's it. Okay, don't you have to do more in this envelopes question. I think that will coming from envelope, but just for your own knowledge. Okay, sometimes 3 marks question is coming, suppose. Okay, suppose find the of parabola y square is equal to 4x. Okay, so first you have to find the normal of the equation. Okay, so do you know how to find the normal? This thing is your done in your class 12 level. Basically first you have to find the derivative, right? 2y into dy dx is equal to 4a right. So from there you are getting 2, if you cancel it 2, so dx by dy, if you find, to a, right? Now you know what are the equation. Y minus y1 is equal to minus dx dy, so minus y by 2a into x minus x1. Okay, I think here there is some parameterization also. Okay, so if you consider the parameterization like at square comma 2at or something. Okay, so this is will be your 2at, right? And this will be your 2at, so because then this will be little bit easy, otherwise you have to do some simplification. Okay, so what you are getting, y minus 2at equal to, here you see 2a 2a cancel, equal to minus t into x minus a t square, right? So you have y is equal to minus xt plus a common so this is your equation. Okay, now this is done. Now your job will be, you have to find the envelope. Here you can think here t is your parameter. Okay, so you have to derive with respect to t, right? So you can write this is your x, y, comma t. You see a is already given, right? So from there you have get that 3at square will be your x minus 2, right? So 3t square is equal to x minus 2a. Now this is your, suppose I am not renaming from 1, but you have y is equal to minus if you take common minus t, so you have x minus 2a, right? So this is, you have x minus 2 is equal to two a tq. So you can say your t is like y by 2a or to 1 by 3 like thing, right? So if you substitute this thing in your 2, so this is your 2 into, so 3a into t square, so minus y by 2a whole square is equal to x minus 2a, and there is 1 by 3, so 2 by 3. So whenever you have square you can ignore your minus thing. Okay, so if you do the whole cube both side, so 3a into y square by, this is also a cube, right? 4a square equal to x minus 2a whole cube. So from there you, I think a square and a cube, if you cancel you have a only here, right? So 27 a y square is equal to 4 into x minus 2a cube. This is the equation of your envelope. Okay, so in this way you have to find the envelope. Okay, anyway, so I am stopping the this class here. Okay, if you have any doubt you let me know in the WhatsApp. Okay, bye.